All right, so number 4 we started, but we weren't filming. We had ran out of storage, so we're starting up again. So nitric acid, which is aqueous because it's an acid and because it's in a double replacement, reacts with aqueous potassium rubidium sulfide. So KRBS is your formula, and that's aqueous, forming hydrogen sulfide. So sulfur is in group 6, so we need 2 hydrogens to satisfy it. And that's a gas, but we're not done because we need to make sure that we pick up everyone else. And so we've got KRB and NO3 need to be together. And so this is a positive 1, this is a positive 1, so the total is a positive 2. This is only a negative 1, so we need 2 of those, and that's going to be aqueous, and we really don't care about it. So balancing HNO3, KRB, and SHNO3, KRB, and S. Okay, so one of these, one of these, one of these, and one of these. H on this side is 2, NO3 is 2, KRB is 1, and sulfur is 1. So I think I'm going to go for the NO3 first and put a 2 there, which changes that to 2 and that to 2, and then we're totally balanced. So complete ionic is 2H plus 1 aqueous plus 2NO3 aqueous, negative 1, plus KRB, positive 2 aqueous, plus S, negative 2 aqueous, goes to H2S gas, plus KRB plus 2 aqueous, plus 2NO3, negative 1 aqueous. So we're looking at the net ionic, and we care about H2S, so we don't care about that or that or that or that. So 2H1 plus aqueous plus S negative 2 aqueous goes to, whoopsies, never an equal sign, what am I doing? Goes to H2SG. That's it. Awesome. All right, aqueous potassium iodide plus 1, negative 1. So Ki reacts with, and that's aqueous, lead nitrate. All right, so we can see here that lead is a positive, whoopsies. That lead is a positive 2 because that's its Roman numeral, and nitrate is a negative 1. So we'll have Pb, NO3, parentheses, need 2 of those, in solution, and that's aqueous if it's in solution, forming lead 3 iodide, so Pb, and it's giving up 3, so I needs to have 3, and solid, so that's back to precipitate, plus something else. What do we need? We need a K and an NO3. KNO3, aqueous. So balancing, we've got KIPBNO3, KIPBNO3 equals 1 equals 1 equals 1 equals 2 equals 1 equals 3 equals 1 equals 1. All right, so I think I'll go for the iodine first and do a 3 here, changing that to a 3, changing that to a 3. We'll have to change that to a 3, and NO3 goes to a 3, which isn't great. So then we put, oh lordy, lordy, lordy. I'm going to cheat and look at my answer key. And this should be a 2. I did the work, I just don't want to figure it out again. And then a 2 over here. And so my numbers now become 2, 2, 1, 2, 2. What in the what? Lead 3. Iodine. Okay, I'm going to need some time to think about this for a minute and see what happened, because this has got to be a 3. Oh my goodness, is that a 2? Oh, it's a 2. So that's my problem. Well, then of course this works. 2. So even I could have done that without thinking. Okay, so this is a 2. And PB is a 1. And this should be a 2 then as well. Yay! There it is. Okay, so complete ionic is 2K plus 1 aqueous plus 2I aqueous, and that's a -1, plus PB positive 2 aqueous plus N2NO3 aqueous -1 goes to PBI2 solid plus 2K plus 1 aqueous plus 2NO3 -1 aqueous. So all we care about is this solid here, and so I can get rid of K and NO3, and then I have 2I -1 aqueous plus PB plus 2 aqueous goes to PBI2 solid. Awesome. That's it.